In this question, we've got two sectors of circles which are mathematically similar being compared to each other. Now that key phrase there of mathematically similar, as we see written down here, should instantly bring up the topic of scale factors. So length scale factor, area scale factor, and volume scale factor. These relate to shapes that are mathematically similar, and we can scale up and down the various properties of it. What we want to be doing in this question is we're told the area of the larger sector, we want to calculate the area of the small sector, and then the size of the angle ACB. So the first thing we want is the area of the smaller sector. Now what we have to do in order to be able to do this is we have to figure out the area scale factor, and then what we have to do is multiply the area of the bigger one by this to reduce it down. So first thing we need to do is figure out our length scale factor. So we take the length scale factor, which is the ratio of the two sides we know, and we know we're going to go bigger to smaller, so we take the smaller one over the bigger one. So our length scale factor in this case is going to be equal to 30 over 50, or 3/5. Simplify it down. Now we know to get the area scale factor from our length scale factor, we square it. So in this case, our area scale factor is 3/5 squared, which ends up giving me 9 over 25. Now that I've got that, what I'm able to do is take the area of the bigger one, multiply it by this area scale factor, and it will give me the area of the smaller sector. So what I can then do is I can say the area is equal to my 9 over 25 times the area of the bigger one times 2750 square centimetres. Plug that into a calculator. When you do, you get 990 square centimetres. So there you go. That's the area of the smaller sector. That's part A done. Part B wants me to calculate the size of the angle ACB. So it wants the size of this angle in here. So it wants the angle at the centre of this sector. Now, in order to do that, what we have to figure out is what property of the sector we have and then work back. Well, we're told here that we have the area of the bigger sector. So we know then that our area of our sector is equal to theta over 360 times pi r squared. Now in this one, theta represents the angle here. So it's going to represent this angle here, ACB. What we have to do is figure out the parts in this we know and then rearrange it for the angle. Well, we know what the radius is. The radius is given to us in the question. We know pi and 360 are both just numbers, and we know the area because it tells us here. So what I do is I rearrange this for theta and then solve it. So in this case I'd say fine, so I can rearrange that. I could say that theta is equal to 360 times the area of the sector divided by pi r squared. Then I just plug in my values and I can get going with it. So I then say fine, so it's equal to 360 times the 2750 all divided by pi times r squared, so pi times 50 squared. And again, this would come up in a calculator paper, particularly with these numbers. Just plug it all in one go and see what you get. So I end up getting 126.05, and then numbers continuing on. Round it to one decimal place and I get an angle of 126.1 degrees. Now, something to point out. There are a couple of ways of doing this first part here. So for example, if I'd done bigger over smaller, I could have divided at this stage rather than multiplied to be able to get my new area. So that's one alternative way we could have done it. Questions like this, there tend to be one or two different methods of doing it. The key thing is you have to make sure you pick the method that one, gets it right, but two, resonates best with you so that you understand what you are doing. You have to be able to understand it so you can follow your working, follow it through, and then if need be, go back and correct it and fix any little errors you have done. You have to understand it, bottom line. Use the method which resonates best with you, make sure you get that right final answer, and make sure you include the units. So square centimetres for the area, degrees for the angle.